So in this video, I'm going to tell you how I was able to reduce my AI SaaS token cost. So previously, with my old architecture, I was somewhere getting around 6.3k token per request, but with the new architecture, it was reduced down to 1.7k, right? So I have run the test cases as well. So you'll see that afterwards. Now, business owner on my platform can create a max of 60 prompts, 20 flows, and 40 functions. So I will tell you what prompts, flows, and functions are. So this is my SaaS dashboard. Now, currently, I have trained the whole bot on IKEA. So I want this test to be as real as possible. Now, coming to prompts. Now, I offer 60 prompts to a business user. Prompts are basically just WhatsApp messages, right? That you can just create and the AI can pick this message and send it to users. Then there are flows. Flows are basically forms inside WhatsApp. So you can have a booking form, you can have a schedule form. There are functions. Functions are basically just API calls that you can have so that the AI can interact with other systems. So AI can fetch data using a get or send data using a post. Now, coming back to the architecture. So this was my previous architecture. As you can see, what I was doing here was as soon as I get a user query, I was sending it to fetch my knowledge base that were all the links that are stored in the Pinecone. And in parallel, I was fetching all the flows, prompts, and functions from the DB. Now, in total, it was up to 120 tools. So then, after fetching both of them, I was sending those. First, I was injecting flows and prompts in the system prompt itself. So 20 flows and 60 prompts were injected directly, and the remaining 40 functions were binded to the AI so that the AI can call it whenever the AI wants. Now, there are three more functions, as you can see. These three are constant functions. The first one is an handoff function when the AI thinks it needs to send the conversation to a human agent. Then there is a send message function. Send message function is basically for sending prompts, and send flow is for sending flows, right? Now, this whole architecture was costing me around 6.3k tokens per request because I was embedding because I was injecting all the 120 tools, even if they are not necessary, even if the AI calls only one tool or two tool at max at a time, then too I was injecting 120 tools. So I did some research and I found tool search tool. Now tool search tool is basically from Anthropic. The main limitation here is it's only for Claude models, right? Now, search tool does is it basically reduce your context size by 85% by loading the context with only 3 to 5 tools that the cloud actually need, right? Basically, Anthropic has created a tool that can search other tools, right? You can define the tool in two ways, a regex and BM25. So the AI can use regex to search other tools or natural language query to search other tools. You can see in limitation, it only supports Claude models, right? Then it's good for 10 plus tools. If you have 10 plus tools in your system, it's really good. And I have 120 tools, right? So I need to search and find a new alternative for this. Came across something known as Prefilter. Before going to Prefilter, I will show you what my previous architecture results were. So this is my previous architecture. Now you can see I ran 16 test cases, right? And this is for now all the test cases you can see tools provided were 43. Tokens per request is 6.5, 6.4 time taken, right? Now coming at the end, 16 test cases run. Average latency is 3 seconds. Token is 6,000. Lowest is almost 6,000 and the highest is 7,000. So basically, we are just bloating the whole context with 120 tokens when the AI only uses one function, flow, or the end of tool, right? So a better alternative that I found was pre-filtering. Now let's see what pre-filtering is. So how this works is beforehand, what we do is we will embed all our function prompts and flows in Pinecone, right? We will embed and save them there. Now, when a user query comes, we will embed this user query for retrieval. We will use this to retrieve the KV, that is the knowledge base, and then we will use the same query, embedded query, to retrieve from the Pinecone. We will retrieve top 15 matches for that query. So a top 15 matches can be anything. We can get three functions or five functions, seven prompts. So the main idea in this architecture is to embed all your 120 tools in Pinecone so that whenever a new user query comes, we will first embed that user query for retrieval. We will get top three matches for our knowledge base from Pinecone. And in the same way, we will get top 15 matches for our flows, prompts, and functions. So, which are the most relevant function, prompts, and flows for that specific query from Pinecone. So by doing this, you can see we get 15, the top best 15 tools for this specific user query. Previously, we were getting all the tools. Now we are getting the top 15 tools. So you can see how we have reduced the context here. Then we'll do the same thing in the system prompt. We will inject the flows prompts and we will create, that is, we will bind the other functions to the AI directly. So the other architecture remains the same. We will just add a new step here. Now you can do this in parallel, right? Once you do this in parallel, the time taken will not change. Or if you are worried that this will cost you extra latency, if you do both of these things in parallel, then I don't think so that it will cost you extra latency. Now coming to the results. Now these are the pre-filter results. So you can see the one thing I like is the accuracy. It's 98% accurate. So you have to run, we ran 16 test cases. The average latency increased by 1.3 seconds or 1.4 seconds. But that's good because, as I told you, if you do this in parallel, you can reduce the latency. Currently, I'm not doing that. The other thing you can see is average token call. It was 1.7. It was 1.7K tokens, and the lowest was 1.4. So if you compare this with no pre-filter, then you can see there is a huge difference. And if you talk about accuracy, pre-filter, I can guarantee that it's 98% accurate. So let's see. Here it called the handoff tool. Here it called the handoff tool. For case 15, here it called the handoff. Here it did the general response. That's fine because for career inquiry, I didn't provide any function, tool, or prompt. Then here in test case 14, it called check gift card balance. It did a handoff here. It did a general response. That's fine because there is no tool provided. Then for flow, call the apply file. So if you check every single one, it's pretty accurate, right? So you can see that how adding just a pre-filter step can reduce your token cost for your AI SaaS.